Hello viewers, this is Mathematics Made Easy channel. My name is Israel, aka Because He Cares. Today's topic, we're dealing with equation with non-rational roots. Example here, if m raised to power 2 equals 16, then m equals plus or minus 4. What happened here, we use the raised to power 2 to get the root of 16. That's why we could arrive at plus or minus 4, because square root of 16 is 4. Hence, if x open bracket x minus 3 close bracket raised to power 2 equals 16, then x minus 3 equals plus or minus 4, like we said up here. Then, and x equals 3 plus or minus 4. So our answer will now be x equals 7 or x equals minus 1. What really happened? Therefore, x equals 3 plus 4 equals 7, or s equals plus 3 minus 4 equals minus 1. Let's see the another example here. They said solve the equation, this equation, open bracket x plus 3 close bracket raised to power 2 equals 7. From here now, if x plus 3 close bracket raised to power 2 equals 7, then x plus 3 equals plus or minus square root of 7. We transfer this square root to this side. That's why we could arrive at plus or minus square root 7. So x equals minus 3 plus or minus root 7. Square root here before that will transfer here, make this thing to become square root of 7. Then this positive sign will transfer to this side to give us negative. That's why we arrive at this minus 3 plus or minus square root 7. Then at the same time, this is the reason why we said this thing is non-rational, because we can't go further again. This is how we will stop. But the square root that we have here, if you look for the square root of 7, we could get like square root of 7 is equal to 2.65, which is not perfect. That's why we said is a non-rational, not a perfect square. So let's look at the first example here. Let's work it together and see what we're going to get. From what we have on the chalkboard here, example 1, x minus 2 open bracket close bracket raised to power 2 equals 1 over 4. So from here now, we come back, we say x minus 2 equals the raised to power. Once we come to this side, this thing returns to plus or minus square root 1 over 4. Then x squared equals 2 plus or minus instead of looking for raised to power again, square root of 1 over 4 is half. So from here now, therefore we now expand it. Therefore x equals 2 plus 1 over 2, or x equals 2 minus 1 over 2. So from here now, we go further, we pick it, x equals 2 over 1 plus 1 over 2. So we look for something that can divide this denomination here, the down one. So we pick 2. So if we now say 1 in 2, we still see 2. Times 2, 4, plus 2 into 1 times 1 is 1. So here is now become 5 all over 2. That means x equals 5 all over 2. We can still divide further. So 2 here, 2 can go here 1, 2 here 2. So x here equals 2 whole number 1 all over 2. 2 whole number 1 over 2. So let's come to this other side. So this one will now become x equals 2 over 1 minus 1 all over 2. Then we look for what can go between the denomination here. So we pick 2. 1 here, we see 2. 2 times 2, 4. Again, minus 2 into 1. 1 times 1 is 1. So from here now we have 3 raised to power 2. That means x equals 3 raised to power 2. Then it can still go further. That's what we now have here. Answer or x equals 1 unknown number 1 all over 2. So this is the answer that we have here, because this to show that our equation here is under non-rational roots. Let's look for another example. Example 2. So we have x squared x2 x minus 1 raised to power 2 equals 9 all over 25. Like we said here, we will transfer the raised to power to this side to give us plus or minus. So it will now become x minus 1 equals plus or minus square root 9 all over 25. So we'll go further. We'll transfer this one to this side to give us x equals 1 plus or minus. If you look for this root of this square root of 9, this equals square root of 9 is 3, then square root of 25 is 5. So we put it here that square x equals 1 plus or minus 3 raised to power 5. So we now expand again. We expand it too. So x equals 1 all over 1 plus 3 over 5. Or the second one, x equals 1 minus 3 over 1, this one over 5. So let's finish this first part. So from the denomination here, we pick the bigger one. 5 here, 1 in 5, we see 5. 5 times 1, 5. Plus 5 in 5, we see 1. 1 times 3 is 3. So we add these ones together, it's going to give us 8 all over 5. So therefore, let's see x equals. So therefore, 5 here 1, 5 here, 5 in 8, we see 1. So that means x equals 1 whole number 3 over 5. Then let's do the second one. From here to, we look for the higher one. We pick 5 to divide the equation. So 1 in 5, 65. So 1 times 5 is 5 minus 5 in 5, 1 times 3, 3. So if you remove 3 from 5, it will give you 2. So 2 over 5. So x here equals 2 over 5. So our answer now is or x equals 2 all over 5. If you can look at this equation too, it shows that our answer and the root are non-rational equation. I hope this channel added value to you. Please help us to like our channel and also to subscribe. Till our next video, I'm yours because he cares. Thank you.